Assalamualaikum and hi to everyone. We are Group D from Lab S21. Today we are going to present our neural network project titled Diabetes Risk Prediction using a multi-layer perceptron MLP with Keras and TensorFlow. My name is Wan Muhammad Akil and I will be presenting alongside my team members Eugene Hao, Sun Boming, Shakir Hamali and Anis Najwa. Let's begin with a bit of background. Diabetes is a chronic and potentially life-altering disease where the body cannot properly regulate blood glucose levels. Over time, if left unmanaged, it causes severe damage to vital organs like the kidneys, heart, and eyes. To understand the scale of this issue locally, according to the International Diabetes Federation in 2024, a staggering 21.1% of Malaysian adults are currently living with diabetes. This brings us to our core problem statement. The traditional method of diagnosing diabetes relies heavily on clinical visits and laboratory tests such as HbA1c or fasting glucose tests. Because of this barrier, many individuals, especially those in rural or undeserved areas, remain undiagnosed until serious complications have already occurred. Therefore, there is a crucial need for an intelligent, data-driven tool that can enable early and accessible risk screening for everyone, bridging the gap between delayed diagnosis and early intervention. To address this problem, our team set out with four main objectives. First, to build a deep learning artificial network, specifically a multi-layer perceptron MLP using Keras and TensorFlow for binary classification. Second, to carefully pre-process and analyze a real-world healthcare dataset by adhering to the industry standard CRISP-DM methodology. Third, to evaluate our model performance comprehensively using metrics like accuracy, precision, recall, F1 score, and ROC-AUC. And finally, to identify which features or health indicators contribute the most to a person diabetes risk. To keep our project focused and achievable, we have defined a specific scope. Our target demographic is strictly adult patients, meaning individuals aged 18 and above. We are focusing specifically on type 2 diabetes. The model task is a binary classification. It will simply predict whether an individual is diabetic or non-diabetic. Lastly, the entire system is developed and implemented in Python utilizing the powerful Keras and TensorFlow frameworks.
Hello everyone, my name is Anis Najwa. I will be walking you through our project on diabetes prediction. Let's start with a quick overview of our dataset. We initiate our project with a raw dataset of 100,000 record sources from Kaggle. After a thorough cleaning process, we retain 78,273 high-quality records. Our analysis evaluates 8 critical health indicators, including gender, age, hypertension, heart disease, smoking history, BMI, HbA1c level, and blood glucose level. As you can see from the chart, we are dealing with a heavily imbalanced class distribution. 90% of the data represent individuals without diabetes, while 10% represent those diagnosed with diabetes. This imbalance is a crucial factor accounted for during modeling. Next, to ensure a structured and reliable approach, our project strictly follow the industry standard CRISP-DM methodology. This pipeline takes us through 6 essential phases. First, business understanding to define our goal. Second, data understanding to explore the data. Third, data preparation to clean and format it. Fourth, modeling where we build our predictive architecture. Fifth, evaluation to assess performance metrics. And finally, deployment to bring the trained model into action. Next, diving deeper into the data preparation phase. Our pre-processing involves 3 major steps. First, cleaning. We remove duplicate, filter out invalid gender, restricted the data set to adult age 18 and above, and applied IQR-based outlier removal on BMI, glucose, and HbA1c level. Next, anomalies found. We discovered that exactly 27.32% of row share an identical BMI, a clear artifact of mean imputation. We also identified decimal value in infant age and handled no info value within the smoking category. Lastly, transformation. Finally, we labeled encoded categorical features like gender and smoking and carefully fitted a standard scaler only on our training data to prevent any data leakage.
Hi, I'm Sun. Now I'll explain about our AIN architecture. So for our model architecture, we built a multi-layer perceptron. First, the input layer takes in our egg patient health features the data then pass through the three hidden layer containing 128 and 64 and 32 neurons, which all use the ReLU activation function to learn complex patterns. To prevent the model for just memorizing the data, we added the dropout. Finally, the output layer uses a single neuron with a sigma function, which calculates the final probability of the patient having diabetes. The model is tied together using the Adam optimizer and binary cross entropy loss. So next, then this is the training process. It starts with the forward propagation where patient data flow through the network to make a prediction. Then back propagation calculated the errors. Then the Adam optimizer updates the model weights to fix those mistakes. Because our dataset has much fewer diabetic patients than healthy ones, so we use the class weighting to force the proton to pay extra attention to the minority diabetic case. We also apply the early stopping, which automatically holds the training if it stops improving for TED approaches. To ensure our model was stable, we ran a 5-fold cross validation and achieved a solid mean accuracy of 89.25%. So now let's look at our result performance. The model did exceptionally well, achieving a high text accuracy of 91.72% and a ROC AUC score of 0.9722. If you look at the confusion matrix, you can see our model successfully predicted 1,042 actual diabetic cases, but our most important metric was our 86% recall. Because we priority recall because in healthcare missing a real patient is very dangerous and delays their treatment. A false alarm is much safer than because the patient simply takes a follow-up test by successfully catching 86% of the actual case. Our model is a safe and highly reliable screening tool. Now next, we will be demo about our system. Thank you.
For this slide, it shows which the most features affects the diabetes prediction. Based on the graph, HbA1c level has the highest importance at 19.40, followed by blood glucose at 12.78. This means C depends on these two medical factors when predicting diabetes risk. Other features like age, BMI, hypertension, gender, heart disease, and smoking have smaller effects. This result makes sense because HbA1c and blood glucose are direct clinical indicators for diabetes. Next, we go to demo.
Hi, good day to Professor Burhanuddin and also my fellow friends. I'm Eugene Hao. I would like to present our group project demo using Jupyter Notebook. Firstly, I'll introduce my files here. So we'll have the diabetes and Python file, which is our main training code as we run it, and it will save several files like as for the model files, which is this one, model.grass, and it will produce another 3 files also pkl files. The scalar.pkl will be store the scalar details, and these two gender smoking.pkl file will be store the encoding details, and we'll include also the end result image which for the evaluation metrics graph. And also another one is the model result.txt where it's store our details of the also evaluation metrics. So The last part will be this predict.py is actually used to load the safe model and also make instant prediction without retraining. So let's start for the demo. So firstly, I'll change my directory to the folder where it includes all my files, just what I just showed just now, the Python file. So I just run the Python file predict. So this is actually the interface for to input the patient details and predict their diabetes risk. They said put male, then 62 years old, has hypertension and also heart disease. Currently still smoking with BMI 33, 6.3 level HbA1c and also blood glucose 172. So this will be the result for the system to show whether the probability of the patient getting diabetes is high or low. So that's all from me. Thank you.
Next, to conclude, we successfully built a deep learning ANN model using Keras and TensorFlow for diabetes risk prediction. The model achieved 91.72% test accuracy and 0.9722 ROC AUC, which shows strong performance. The recall is 86%, which is important because in healthcare screening, we want to reduce missed diabetes case. The most important predictors were HbA1c and blood glucose, which also match clinical knowledge. Lastly, cleaning the dataset by focusing on other data help improve the model quality and reliability. Next for Q&A session.
All right, any question for our project?
Yes, I have a question. Were there any case the model predicted incorrectly, and why?
Oh yeah, there's actually the system may predicted incorrectly because some of the borderline patients with mixed indicators, for example, a slim patient with high glucose but no other risk factors was predicted as non-diabetic. So on our investigation, we also found that most of the data set inside the Kaggle that we use is non-diabetic. So it actually affects how the model learns to learn the correct dominant pattern, but however, it's actually quite rare to happen. All right, thank you.
Okay, thank you.